We're going to start this up. It'll just take a second for me to get to the Elmo. Okay, it's a coming. Trust me, it's coming. Anyway, here we go. We're going to start Unit 2 review. As soon as we start up, there we go. Let's see, maybe if I zoom in just a little bit, easier for you guys to see. Zoom in just a little bit more. Okay, so we start out with bases that are the same being multiplied. That means I can add their exponents. So the base comes to one base. Then I get x plus x minus 4, which is going to then give me 3 to the 2x minus 4. Done with number 1. Number 2, notice that the x here is the only thing that's being raised to the negative power, not the 2, because it'd be parentheses if it was the 2 as well. So we're going to have 2 over, this moves down, the negative becomes positive, x to the 6th. Number 3, 20 divided by 5. Hey, don't forget you know how to divide 20 by 5. It's 4. Bases here are the same. 5 is smaller, it comes up. And we subtract. So this is going to be x to the 20 minus 5, which then is 4x to the 15. Here, 18 divided by 3 is 6. Again, take a look. These bases are the same. So I take the smaller one up to the larger one. Sorry. There we go. Now you can see it. So we have x to the negative 8. X to the 4th. Negative 8 is smaller, so it's going to go up to the top. So it's going to be x to the 4 minus a negative 8, which can become plus. Here, negative 3 is smaller than the 6, so it's going to come down. So on the bottom, we're going to get y to the 6 minus a negative 3. That's going to become plus. That gives us 6x to the 12 over y to the 9th. Done. Notice the parentheses here, which means that this power is going to be taken to both the 4 and the x to the 4th. So 4 to the 3rd, x to the 12th. Remember, when you have a power to a power, you multiply. This 4 has a little power up there. It's a 1. We never write it, but it's always there. 4 to the 3rd is 64, x to the 12th. Okay, taking a look here. Again, multiplication tells me between the 5 and the 3 that I can take this 2 and multiply it to both the x and the 1. So that's 5 squared times 3 to the 2x. Now 5 squared is 25. And you could say that 3 squared is 9. So it's 25 times 9 to the x. You cannot multiply the 25 and 9 because 9 is being raised to the x power. But we're there. We're done. Okay, it says rewrite 5x to the 4/3 as a radical expression. Okay, so remember, the 5 is not included, just the x here. So we would say 5. Then we'd have a root. What root is it? Well, the root's on the bottom. So 3x to the 4th. Now, you would love to say you're done here, but take a look. 3, and this is 4. That means this x to the 4th is the same thing as x cubed times x. So I could take the cube root of both of those. This then would cancel. So I have 5 times x times the cube root of x. And that is your final answer. Okay, this guy here. I would tell you to get 3 all by itself. So multiply by 2 over 1. Multiply by 2 over 1 to get rid of that 1/2. That's 3 to the x equals, this 2 will get rid of that 2. We get 9. 9 is the same thing as 3 squared. Hence, x must equal 2. Done. Okay, 1 over 64, and this is 4. So I know I need to move it down. So x must be negative, because that's the only way to get the 4 to move down to the bottom and become a 64 on the bottom. Now, 4 to what power is 64? Well, that's 3. So 4 to the negative 3 is 1 over 64. Think about it. 4 to the negative 3. Negative moves it down. 1 over 4 cubed. 4 cubed is 64. Sure enough, x is negative 3. Okay, let's go ahead and multiply by 2/3 here. So the 3's will simplify, giving us 2 to the x equals. 2 goes into 64 32 times. 1 over 32. Again, we're getting that dilemma where we have a 2 to the x. Then we have a 1 over 32. That would tell me that this exponent, again, needs to be negative to move the 2 down. So the exponent's got to be negative. And then 2 to what power is 32? That's 5. Done. All right, there's nothing to move over here. But if I look at 3 and 9, 9 is the same thing as 3 squared. And 16 is the same thing as 4 squared. Which really now, because these are both raised to the second power, I could write it as 3 over 4 squared. And that equals 3 over 4 to the x minus 2. Bases are the same, exponents must be the same. Hence we get x minus 2 equals 2. Add the 2 over, we get x equals 4. And there's our answer, x equals 4. Okay, we're done. Look at number 12. Graph the following function. Tell the key features. Well, so here's the deal. No, it's not a quadratic because it's not a squared. It's a 1, so it's got to be linear. Okay, if it's linear, this is in what's called point slope form. This is the x value still, opposite of what's inside. That's the y value, same as what's on the outside. So 2, negative 5 is a point on my graph. Makes sense if I put in a 2. 2 minus 2 is 0. Negate 0 is 0. 0 minus 5 is negative 5. 2, negative 5 is a point on the graph. This right here is the slope. Right here is the slope. Slope is negative 1. Means it's going to come down 1, over 1, down 1, over 1, or up 1, back 1, up 1, back 1. So it's looking something like this. You go a couple more just to see the or the x-intercept right there. So there it is. So x-intercept was at negative 3. So that's negative 3, 0. The y-intercept is at 0, negative 3. That's interesting. Doesn't usually happen that way. Increasing from left to right, this graph is never going up. It is always going down. Hence, it is never increasing, but always decreasing. Maximum value. Well, this thing goes up to infinity, so there is no max. And it does go down to negative infinity, so there is no min. Asymptote, we'll look at end behavior in a minute to determine that. Let's go back up here to the domain. How far to the left can I go? Negative infinity. How far to the right? Infinity. So therefore my domain is negative infinity to infinity. The range, how far down can I go? Does this graph go? Negative infinity. How far up does it go? Infinity. So negative infinity to infinity. Positive interval would be above the x-axis. Looks to me like here's the line above the x-axis right here. So any value, any x values over here up to that point, it's going to have a positive graph. So this point right here is our key. So negative infinity up to negative 3, it's positive. Then look, from negative 3 on this way, the graph is below the x-axis. Hence, from negative 3 to infinity, it's negative. Concavity has to have curvature to be concave, so there is no concavity here. Okay, to determine your asymptote, look at your end behavior. Your end behavior says as x goes to negative infinity, as x goes to negative infinity, where's this graph going? Oh, it's going up to infinity. As x goes to infinity, that's what this is saying right here. As x goes to infinity, this way, where's the graph going? Oh, it's going down to negative infinity. Average rate of change is slope from x equals 2. X equals negative 2 to 2. 2 minus a negative 2. Take 2 and plug it in. Well, we know that's negative 5 because 2 minus 2 is 0. Negate 0 is 0. Minus 5 is negative 5. Plug negative 2 in. Negative 2 minus 2 is negative 4. Negate negative 4, that's 4. 4 minus 5 is a negative 1. Okay, so now we can make those become plus. Negative 5 plus 1 is negative 4. 2 plus 2 is 4. Negative 4 over 4 is negative 1. There's our average rate of change. Okay, done with the first page. Going to the second page. Here we go. Graph it up again. X squared plus 1. If you don't know, make a t-chart table, right? Your x and y's. If you want, go to negative 3 to 3. That'd be the magnificent 7. Here's just the fab 5. Negative 2 squared is 4. 4 plus 1 is 5. Negative 1 squared is 1. 1 plus 1 is 2. 0 squared is 0. 0 plus 1 is 1. 1 squared is 1. 1 plus 1 is 2. 2 squared is 4. Plus 1 is 5. Okay, negative 2, 5, negative 1, 2, 0, 1, 1, 2, 2, 5. Oh yeah, here we go. This thing is a parabola. Okay, x-intercepts. Notice it never crosses the x-axis here. Not applicable. Y-intercept crossed it at 1, 0, 1. Increasing intervals. So increasing again is going up from left to right. So as I look from left, look from left to right, right here, it starts to go up. Hence, from 0 to infinity, my graph is going up. So that's going to be increasing from 0 to infinity. Means from negative infinity to 0, the graph was going down. So from negative infinity to 0, the graph's going down. Maximum value. This graph goes up to infinity, and there is no maximum other point, so this is NA. Minimum value. Take a look. This is the absolute lowest that the graph goes, so it is a global min at 1. Domain. How far to the left can I go? Negative infinity. How far to the right can I go? Infinity. So this is negative infinity to infinity. Range. How far down can I go? 1. How far up can I go? Infinity. So that's 1 to infinity. Notice the bracket on 1. Positive interval. This thing is always above the x-axis. So from negative infinity to infinity, it's above the x-axis. Negative, never. Concave up like a cup holding water. If I poured water into this thing, would it hold or would it go, when it run down as negative infinity, it would hold. Over what x intervals? From negative infinity to infinity. Concave down, never. Asymptote, look at your end behavior. As x comes out this way to negative infinity, where's my graph going? Up to infinity. As x goes to infinity, where's my graph going? To infinity. Because these are not a number, there is no asymptote. Okay? Average rate of change, slope, from negative 2 to 2. 2 minus a negative 2. Put in the 2 here. 2 squared is 4. 4 plus 1 is 5. 5 minus, put in negative 2. Negative 2 squared is 4 plus 1 is 5. 5 minus 5 is 0 over 4. Therefore, it's 0. Okay, 14. Look at this exponential decay. How do we know it's exponential? Because the x is in the exponent. If you don't know, make yourself a table. This is your y value, though. Your y-intercept's at 9, and then it's just coming down. Looks something like that. Because there is no vertical shift up or down, that asymptote's going to be right here on the x-axis. That's where it always begins. X-intercept, there's not going to be one. It's never going to touch that x-axis. Y-intercept, we said, was 9. Again, we got that from right here. Increasing, so from left to right, where's this graph going up? Never. But it is always decreasing. Max value, look at it. It's going up to infinity, so there is not a max value. Min value, it's coming down really close to 0, but it's never going to quite get there. And it's always going to keep getting lower and lower, so not a minimum. Domain, how far to the left can I go? Negative infinity. How far to the right? Infinity. Range, how far down can I go? Almost to 0. But notice there's not a bracket, it's parentheses, because it's not including 0. How far up to infinity? Positive, this thing's always above the x-axis. It's never negative. Concave up. If I pour water in here, the water will run this way, it's true, but it'll never run down to negative infinity down here. Hence, this is always concave up. It's never concave down. Look at our end behavior to determine your asymptote. As x goes to negative infinity, where's my graph going? It's going up to infinity. So nothing so far. But here, as x goes out to infinity, where's the graph starting to approach? Starting to approach 0. There's your horizontal asymptote. Y equals 0. Average rate of change. From 0 to 2. 2 minus 0. Plug 2 in. 1/3 squared would be 1/9 times 9 is 1. Minus, plug in a 0. 1/3 of the 0 is 1. Times 9 is 9. 1 minus 9, negative 8. 2 minus 0 is 2. That's a negative 4. Done. Look at 15. Use the graph at the right to tell the key features. Where does it cross the x-axis? Looks like it crosses as 1, 0. So this thing is just continually going down. It's kind of hard to see that, but it's going to continually go down. The y-intercept, that means there's not going to be one. Increasing. So from left to right, looks like this thing's always increasing. But notice that there is no graph over here, so it really starts at 0 to infinity, never decreasing. Maximum value, this thing just keeps climbing and climbing up. So there is no max. Min, this thing goes down to negative infinity. No min. Domain, how far to the left can I go? Well, it looks like it only goes to 0. How far to the right? Infinity. Range, how far down? Negative infinity. How far up? Infinity. Positive. Well, it means above the x-axis. So it looks like right here it goes above the x-axis. So from 1 out to infinity, it's above the x-axis. That would mean from negative infinity to 1, it's below the x-axis. Concave up. If I pour water on this thing, it's going to run down to negative infinity. It's never concave up, but always concave down. Asymptote. Well, there is an asymptote, but instead of being horizontal, this one is vertical at x equals 0. We'll talk more about those as well. Okay, next page. Okay, it says graph of function has the following characteristics. Positive on 3 to infinity. So I know at 3 has an x-intercept, and then it's positive. I don't know if it goes up like this, if it's going like this. We'll see. Has a y-intercept of negative 2. Y-intercept of negative 2. And behavior as x goes to negative infinity, it's going to get really close to negative 4. So this thing's going to look like this. And then it's going to go up to infinity. Yeah, it looks like that. There we go. Write it piecewise to define the function you're at using a square root, a constant, and a linear. So start out with what you know. Hopefully you all got to there. From here, this is the constant at 2, so I know I'm going to have a constant at 2, and that goes from 4 up to 6. Okay. This one is a straight line, so this one's got to be my linear. This one's got to be my linear. Let's determine its slope. Looks like it's down 1 over 1, down 1 over 1. So it's a negative slope, negative 1. You could put in point slope form, which is x minus an x value. So an x value would be 6, 2. So x minus 6 plus 2. If you wanted to get in slope intercept, you could then distribute, but other than that, that's good right there. That's going to go from 6 to 9. Notice at 9 it's an open circle. So from 6, oops, not that. We're going to go ahead and give you guys a full class ticket right there. It's not going to be equal to. Why not equal to? Because it's an open circle. So pay attention there, right? That means the only last thing we have is a square root. There's got to be a square root of something. Well, what's the square root of 1? 1. What's the square root of 4? 2. That's just the square root of x. From 0 to 4. And you're done. Okay, let's do these last piecewise here. It says graph the following piecewise defined functions. Tell if they are continuous on the domain. So break them into pieces. This piece first, from -2 to 2. So if you need to, make a little T-chart. From -2 to 2. Plug -2 in. -2 squared is 4. Negate -4. Plus 2, -2. Plug 2 in. 2 squared is 4. Negate -4. Plus 2 is -2. We might want to see what's happening in between. So let's plug in 0. 0 squared, 0. Negate 0 plus 2 is 2. Okay, so at 0, it's a 2. -2, we're at -2. And at 2, I'm at -2. Okay. Now, it should be an open circle. This should be an open circle right here. This can be closed because it's equal to. Equal to closed, not equal to open. And it's going like that. Oh, it's a parabola. Yep, open and down. Yep. Constant, 1 from 2 to 3. So from 2 to 3, it's a constant. It's solid at 2. So from 2 to 3, it's this line right there. Okay? Now, last part, from 3 to 7, make another little T-chart. From 3 to 7, plug in 3. 3 minus 3, 0 times 2, 0 minus 2, -2. 7 minus 3, 4. 4 times 2 is 8. 8 minus 2 is 6. So I have a point at 3, -2, and that's a solid point because it's equal. And then 7, 6, it's an open circle. Connect the 2. And there's that is what a piecewise looks like. Is it continuous? No, because I have to take and pick my pencil up and move it. So nope, not continuous. Okay, look at 19. 19 says from -1 to 2. Now we're going to use this. So -1 to the -1 is a half. It's going to be a solid point. 2 squared is 4. It's going to be an open circle. So at -1/2, solid. At 2, 4, open. This thing's kind of going like this. It's exponential growth. Constant 2 from 2 to 4. Neither of them are open. They're both open. So at 2, 2, it's open. And at 4, 2, it's open. Then from 4 to 7, it's going to look like this. So from 4 to 7. 4 minus 4 is 0. 0 squared is 0. Minus 2 is -2. 7 minus 4 is 3. 3 squared is 9. 9 minus 2, 7. Both closed circles. So 4, -2. 7, 7. There it is. Is it continuous? Again, no. Why? Because I have to take my pencil up off the paper. Okay, that's our first video. I'll get another one going here in just a second. Go ahead and stop.